lecture 25, we continue looking at solving triangles, and we're going to introduce a new set of formulas that will provide us with the necessary tools to solve the other two types of triangles that we have not yet been able to solve, the side-angle-side triangle and the side-side-side triangle. You'll notice with those two triangles, for example, if I have a side angle and a side, it's not possible to create a pair of angle and opposite sides so that you have a law of sines equation with only one unknown. In each case, you will have two unknowns. So what do? Also, the same problem comes into play if all you know is three sides of the triangle. Again, you can't set up the law of sines to give you an equation with only one unknown. So we're going to need a different tool. Turns out there's another relationship of the sides of an arbitrary triangle called the law of cosines. And as with the law of sines, I'm going to state it without proof, but point out the fact that we will have an additional video provided where you can see where these formulas come from. That is, they don't just come out of thin air. They can be mathematically derived and proven to be the case. Now, what's interesting about the law of cosines is it is actually kind of a generalized Pythagorean theorem. And why do I say that? If you look at the first one here, notice what I've highlighted in that first equation. C squared is equal to A squared plus B squared. But that's not the entire equation for the law of cosines. It is the fact that there is an additional term off to the side here that makes it the law of cosines. And the point of the law of cosines is that it applies to any triangle. The Pythagorean theorem only applies for right triangles. Okay? This works for all triangles. And there are three versions of it. It depends on which side angle side you want to start with. The first one says C squared is equal to A squared plus B squared minus 2AB cosine of C. Now think of that with this triangle right here. What is on the right hand side of the equation? I'll circle everything that's on the right hand side. We have an A that we might know, a B that we might know, and then minus 2AB times the cosine of this angle, and all of that is equal to the left hand side, which is this C across here. So notice how it relates a side, an angle, and a side to the opposite side from that angle. Similarly, the second one follows the same pattern, only now the opposite side is the B, and it relates B to A squared plus C squared minus 2AC times the cosine of B. Do you see the pattern? Okay, it's almost like this little arrow right here. That's how I think of it in my head, the way that law of cosines relates. And the last one says, let's say the left-hand side is A, then you've got a B squared plus a C squared minus a 2BC cosine of A. So the beauty of this law of cosines now allows us to set up equations when we know three of those pieces. And I'll go ahead and scroll up just so you can see this. Notice in all three of them, in all three of them, all three sides are related. So if I had a side-side-side triangle, I would have three of the pieces of information I need in one unknown. If I have a side-angle-side, in any of the cases, I can set up an equation that is the law of cosines, but only has one unknown in it. So let's look at this one and see what we have. We've got A equals 2, B equals 3, and C is equal to 60. So if I draw it like this, let's say A is down here 2, so capital A would be there. Let's say B is here, so 3 would be over here, and 60 degrees is here, so little c would be over here. So using the law of cosines, I can relate now this side here to these three pieces here. And I'll be able to solve then for c. So c squared would be equal to 2 squared plus 3 squared minus 2 times 3 times the cosine of 60. So that gives me 4 plus 9 minus 6 cosine of 60. And we know cosine of 60 degrees is 1/2. So I have c squared is 4 plus 9. Oh, and I left off a 2 here. I'm sorry. Remember, it's c squared is a squared plus b squared minus 2ab cosine of theta, or cosine of, in our case, capital C. So I left off the 2 from right here. Sorry. So this becomes 12, in fact. 12 times 1/2 gives me 4 plus 9 minus 6, which altogether is 7. So c is going to be the square root of 7. So now I know this side over here is square root of 7, so I could use the law of cosines again. This time, and I'll draw it in a different color just so you can see it, I will use this side here, this angle, and this side together with this. And notice that I have one unknown, namely this a right here, that I will then solve for. So go back to my red pen. I have 2 squared would be equal to 3 squared plus c squared minus, which, by the way, c squared is the square root of 7 squared, minus 2 times 3 times the square root of 7 cosine of capital A. So that's 4 equals 9 plus 7 minus 6 square roots of 7 cosine of A. So this becomes 16. So subtract 16 to the other side. I get a negative 12 is equal to negative 6 square roots of 7 cosine of A. Divide both sides by negative 6 square roots of 7. Gives me that cosine of A is 12 over 6 square roots of 7. Or if you reduce that down, 2 over the square root of 7. So A would be cosine inverse of 2 over square root of 7. By the way, with cosine inverses, we do not have to worry about the two different angles you might get out of it, because we're only going to get one angle out. Remember, oh, let me draw that where you can see it. I'll draw it up here. Cosine inverse is defined on the upper half plane, which is an angle from 0 to 180, which is the angle size that we are looking for. So plugging that into my calculator, I get 40.9 degrees. Now there's no need to apply law of cosines again to get this B. All I got to do now is recognize that B would be 180 minus 60, which is my C, minus 40.9, which gives me 79.1 degrees. Now I've solved that triangle using the law of cosines. Now this example, as you can clearly see, is going to be a side, side, side. We know that across from capital A will be a 4, across from capital B will be a 3, and across from capital C will be a 6. So let's start with these 3 right here. So I put a box around that so you can tell I'm talking about. So you get 6 squared is equal to 3 squared plus 4 squared minus 2 times 3 times 4 cosine of the angle C, which gives me 36 plus or equals 9 plus 16 minus 24 cosine of C. 9 plus 16 is 25, so you subtract out the other side. You get 11 equals negative 24 cosine of C. Divide both sides by negative 24. That gives you that cosine of C is negative 11 over 24. So C is the cosine inverse of negative 11 24ths, which gives me 117.3 degrees. And so now I'll repeat again with another set of angles. Let's say we do these three here to figure out A. So 4 squared would be equal to 3 squared plus 6 squared minus 2 times 3 times 6 cosine of A. So that's 16 equals 9 plus 36 minus 36 cosine of A. 9 plus 36 is 45. If I subtract that to the other side, I get negative 29 equals negative 36 cosine of A. Divide both sides by negative 36. Cosine of A would be 29 over 36. So A is the cosine inverse of 29 over 36, which is approximately 36.3 degrees. There's my A, here's my C, so B is clearly 180 minus 117.3 minus 36.3, which gives me 26.4 degrees. Solved. Just two applications of law of cosines will solve a angle side angle and a side side side. Side angle side and side side side. Just two applications of the law of cosines will solve both of those types of problems. In this graphic, you are given some distances related to Wrigley Field, the home of the Chicago Cubs. The distance from the home plate to the fence in dead center field is 400 feet, as illustrated in that picture. Okay, 400 feet from home plate to the middle of center field. We know that it is 90 feet along any baseline, so it's 90 feet here. And since the baseball diamond is a perfect square, we know this angle right here would have to be 45 degrees because it's the diagonal, because it goes right through second base of the square that makes up the baselines in baseball. So given that we know this length here and we know this distance here is 90, this distance here is 400, the question is, how long is this side here? Call that C. Right, well, clearly we have, since we know this side, and the angle between it, a side angle side triangle. All we got to do to figure out C is apply the law of cosines. So C squared would be equal to the length along, say, the third baseline, which is 90 feet, so 90 squared, plus the length all the way out to center field, which is 400 squared, minus 290, 400, cosine of the angle between them, which is 45 degrees. So this gives me 8,100 plus 160,000 minus, that would be 72,000, because that 90 times 400 would be 36,000 times 2 is 72,000. Cosine of 45, which I'll go ahead and write in as square root of 2 over 2. So C squared would be equal to, now I just stuck all this into my calculator and I got 117,118.3. So take the square root of that and I get 342.3 feet. Done. That is the distance from dead center to then third base, simply using the law of cosines to solve that triangle. And that's the end of lecture 25.